So we have data warehouse, and we do have different databases as well, like different databases. Like example for databases: Oracle, SQL Server, SQL Server, MySQL, Teradata. Any other examples you might aware of the database names? SAP
As
HANA.
for HANA.
Yeah, great. We have IBM DB2, and we have lots of databases. Okay, like MongoDB. Exactly. Impala database. So there are lots of databases, and even as I said earlier, we can also connect to Excel, flat files, MS Access database. So basically, we do have database and data warehouse. Okay, so whatever the database is, right, Oracle or SQL Server, or right, we can use the same terminology. I mean, we can also call this Oracle as database, and we can also use the same data like Oracle as data warehouse. But what actually data warehouse, right? What is meant by data warehouse? And we can differentiate with the databases. So importantly, data warehouse terminology, right? We have to understand the terminology of data warehouse. So data warehouse is nothing but it stores historical data. It stores historical data. So for reporting, right? So to do some analysis, to generate some reports, okay, we generally prefer historical data. So even let me create some sample reports here in Tableau. Historical is like we don't need like uh, 10 years of data or 100 years of data, something like that. Even 4 years of data is fine. 5 years of data is also fine, because in the database level, right? So whatever the databases we do call, right? We have a terminology called as OLTP systems versus OLAP systems. So OLTP systems are also similar to or called as databases, which is OLTP is nothing but online OLTP systems are nothing but online transactional processing systems, and we have OLAP, okay, OLAP systems. OLAP systems are nothing but online analytical processing systems. Understand, right? So, and if you have any questions, let me know. So no issues, no need to worry about that. I will repeat once again. So in general, OLTP systems are nothing but these are transactional databases. We do call it as transactional databases. And OLAP comes under purely into analytics. So we are going to do some analysis. This is our job actually. So we are into data warehouse. We are going to do some analysis on top of existing data. Okay. So that is what OLAP. So OLTP systems are also called as real-time systems or source systems. This is very important, okay? I mean, from where you're getting the data is that particular point is important, right? So that is what source systems, or even we can also call it as real-time systems. So real-time systems or source systems. So by using these real-time systems or whatever the source systems we have, on top of that, we are going to, I mean, there is an ETL team, okay? So this ETL team will extract the data and they will load that particular data into data warehouse by making use of some transformations, okay? So that is what their main job actually. So, but in general, like we have a concept called as, I mean, OLTP and OLAP. Let's try to understand this, okay? So OLTP is nothing but it's like transactional databases, okay? These are transactional databases. It stores real-time data and it is also called as source systems. And generally we do call it as BI systems, business intelligence systems, this OLAP systems. But what actually data warehouse and what actually the important points under OLAP systems are? So subject oriented, time variant, non-volatile, and integrated. Okay, subject oriented, time variant, non-volatile, and integrated systems. We'll go through each and every point. Understand, right? And this is application oriented. And going forward, I'll tell you what actually non-time variant. This is volatile database, and this is non-integrated. But basically, as I said, historical data, right? The first point. Let me connect. So whenever you're going to install Tableau, so you have different connections. As I said, you can connect to multiple databases, like you have lots of connections. And there is the networks. So you can see there are a lot of different database connectivities. So even we can connect to Google Drive. As I said, IBM DB2, you can see Databricks, Azure SQL database, okay, and Amazon Redshift. And importantly, we do have all this like Microsoft SQL Server, right? Oracle, PostgreSQL, even we have Greenplum, SAP HANA, Snowflake, Teradata, understand, right? So a lot of database connectivities. This is what the importance of Tableau, where we can connect to multiple databases. And the important point here is whenever we are going to install Tableau, so we have a folder called as My Tableau repository. Okay, so by default you can find My Tableau repository folder in Documents. Okay, in Documents folder, so we have a automatically will get a folder called as My Tableau repository. I'll help you out individually. So how to install Tableau, and as I said, we have a student license. I'll get the student license so that this will help to work at least for 1 year, the license. Okay. So We have data sources. Tableau has provided some sample data, sample Superstore data. So I have installed multiple versions. Any of the version is also fine. Let me connect to sample Superstore data. I'll showcase what actually the joins and how we are going to establish relationships, the data modeling going forward. Okay. So these are the available tables. I connected to Superstore. You can see sample Superstore, and we have orders table, people, and returns table. If you want to view the data here, you can view, click on view data, and you can understand what are all the columns we have in the database level. So this is the data actually. So you'll understand, but importantly, we have like customer information and the products and the orders, right? Importantly, this is orders related information, like there are some items, brands, but we have some order ID, product name, region, and geographical data, correct? So my point here is we have order date, which is the date data type. One of the advantage, we don't have a column called as year. Do we have year? We don't have this. So one of the advantage in Tableau is like if you have a date related data type, okay, the data type is date, understand, right? So whenever you're going to drag and drop order date into rows, you will get year of order date. I'll come back to this anyhow, or even we can create separate year field. But when you drag and drop any of the date field, you'll get year of order date. So now we have 4 years of data, right? 19, 20, 21, and 22, and double click on sales. So this is where you can go for comparison, right? If you have at least minimum 2 years or 3 years of data, right? You can go for comparison. That's what the point I said here. It helps a lot. That is what data warehouse stores historical data. Okay. So data warehouse stores historical data. Basically, like this particular databases, right? That is what here time variant. For data warehouse time variant, it stores historical data, but this is non-time variant. Okay, this is non-time variant. Databases or the real-time systems are non-time variant because this will store maximum 30 to 90 days of data. It won't store historical data. Okay, that's the reason why, as I say, this statement data warehouse is nothing but it stores all the historical data. That's a basic statement. Okay, and 99, I mean, generally we do create reports or dashboards. We'll work in project on top of data warehouse. Even though we will use the terminology called as database. Hey, what is your database? What is your database connection details? Everything. We do use a terminology called as database only in project level, but we are going to work on data warehouse. That is what it's a data warehouse, but we used to call as database. Okay, so remember that. But in general, what actually database or what actually like this, whatever the file we used to get for the ETL team. So I'll showcase, I'll tell you the life cycle of data warehouse. This is very important. So life cycle of data warehouse. If you understand this, you'll understand the flow of data. So I'll come back to this each and every individual points here. What actually subject oriented, time variant, and I'll compare this. So as I said, we have OLTP systems or like we have databases. So in general, we may have multiple, I mean, this is application oriented. Okay. So in general, there are multiple source systems. Okay. Let's say let's say we have some ATM related transaction data, which is stored in database one. Okay. So whatever the transaction you are going to do over the ATM, right? So that will be stored in a separate database. This is just an example. Okay. Even you can consider only ATM transactions information. You might do some international transactions, right? You might go for international transaction where you can withdraw some amount uh, like in multiple locations, correct? So that will be in different databases servers, and there might be a centralized server, so that will be synchronized and will get proper information. Even we can fetch the bank statement. But let me go with the different applications. Okay, so we have different databases. Like as I said, these are like OLTP systems. So there's a loan information, right? Which stores, we have a separate application stores in database 2, some credit card information stores in database 3, and let's say some insurance related information stores in database 4. So there might be n number of applications. Okay. uh, do you remember, as I said in one of the project, avon avon cosmetics? So they'll get the data for avon cosmetics project, right? They'll get the data from over like importantly like 3 or 4 sources, 3+ applications. Okay, but they'll get the data almost like I have seen like 17 sources. Understand, right? Importantly, these are importantly 3 applications, but there are like 17 sources where they will get the data. But I'll tell you a simple example. Okay, let's say if there is a client called as Adidas, right? You have a Adidas shoe or a sportswear, correct? Where we can purchase Adidas, let's say shoe. What are all the possible ways or possible sources where we can purchase an Adidas brand shoe?
In the
Any
store,
Adidas stores? Yes, perfect, excellent. Stores,
in the mall,
malls, perfect.
Online, like Amazon.
Online stores, like perfect, like Amazon, Flipkart here. There are a lot of online applications, right? Now, when you consider
mhm,
online applications, it's a huge list. Okay, so e-commerce. And this is Adidas stores, or even we have malls, and there might be if like in the malls, right? There might be a collection of all these all these brands. But even there is an Adidas um, website, Adidas site. I mean, the main website, their
mhm.
own website. We can purchase stores, malls. There are lots of online. We cannot list it. It's a huge list actually. But important sources are from they will get the data from Amazon and Flipkart. Even Facebook ads, correct? So they'll navigate to a different sources, but this is completely different. So I mean, different ads, all this. Yeah. So that is what importantly online e-commerce applications. Clear all? You understand, right? So these are the sources, right? So Amazon is the source. You're getting the information. You have to get the sales information from Amazon, as for the Adidas, even for Flipkart, right? So whatever the online applications, they have to get the data from their applications like Amazon or Flipkart. So that is also one of the source systems. That's what the main point. So from where we are getting data is very, very important. Adidas is not selling this like whatever the sportswear, right? So it's not only in stores, right? Not only in Adidas stores. There are multiple applications or multiple sources where we can purchase an Adidas shoe. That's the example, okay? So that is what similar to that. These are individual application, like the Flipkart is an individual application, Amazon is a individual application. There are like lots of online applications where you can purchase Adidas shoe. Similarly, we have multiple applications which is going to store in different databases. Understand, right? So we have like source systems. There might be multiple source systems. As I said, which is also called as OLTP systems. So there are different source systems, and so this is where we do have data, like I mean different applications. Okay, so that's the reason this is called as application oriented. And in general, okay, let's understand this way. In general, we used to get, I mean, not for the reporting team, but there is a concept called as ETL. So there is an ETL team. What their job is, their main job is to extract the data, extract this particular data on a daily basis. Okay, and they'll do some transformations, understand, right? And they will load this particular data into one single database that is called as data warehouse. Clear all? So there is an ETL team. ETL team will take care of the extraction, transformation, and loading. So, I mean, so we have different databases. ETL team, right? So there is an example, like example for ETL tools. Okay, let me give you the list here. Example for ETL tools, like we have Informatica, Abnisio, Data Stage, even SSIS integration tool in MSBI. Okay, SSIS. These are the ETL tools. Example for ETL tools. Okay. So if someone asks like, what is your backend ETL tool? You can straight away tell Informatica, because most of the part Informatica will be used, or Ab initio. I have seen Data Stage, SSIS. These are the more used ETL tools. Okay. Major part is like Informatica. But now you understand, right? So in general, I'll give you some more details, but generally for this ETL team, right, they will get some daily CSV files. They'll also get some daily CSV files, I mean .csv files. And what they will do is, like these .csv files, they will load the data into data warehouse. That's it. There are applications where the business will get the data, and they have to share this particular data to the ETL team. That is what different application related data, they'll get the data, these files to the ETL team, and they are going to do some transformations, and they will load this particular data into data warehouse. So all these applications, all these databases information will be stored in one single database. That is what we do called as data warehouse, or we can also call it as centralized database. Okay. So it mainly the main intention of transformation is uh, like mapping tables, okay, and formatting data. Understand, right? So their main job is like they have to do transformations. The ETL main job is like to do transformations. They have to check the tables. They have to map those tables and format the data. Like if you have a different format, right? So you have to format the data. I'll come back to this, and avoid. They have to perform some calculations, avoiding some null values, avoiding nulls, right? So this is what their main job actually. So there are different databases. I mean OLTP systems. We used to get the data into OLTP systems, and ETL. I mean the business team will share these files like the data, the daily CSV files to the ETL team, and they will do the extraction, and they'll transform the data if required, and they load the data into one single database that is called as data warehouse. And from Tableau, right? So from Tableau, we can connect to data warehouse. Clear? So from here, we are going to connect to different, the data warehouse, and we can access all these tables related to different applications. But this is what subject oriented, okay? What is subject oriented is like collection of all the applications. Collection of all the applications data. Okay, simple, right? So this is what where you can see here. It's a collection of all the applications is called as subject oriented. So we have different applications, right? ATM is an application, loan is a different application. So that is what in general like subject oriented. But do you understand the life cycle of data warehouse? Generally, let's take an example. Why do we maintain only data warehouse? Okay. What is the advantage of data warehouse? I'll come back to this. So data warehouse in general, data warehouse, sorry. Data warehouse, right? So whatever the application, whatever the life cycle we have seen, let's understand this way. If you have different databases, 1 minute. Let me take this. Okay. So basically we have different applications, correct? So the point here, we have individual databases, right? Let's say if you want to do some reporting on top of your ATM related, the ATM related transaction data, first of all, we have to connect to database one, correct? Again, if you need some information from loans, you have to connect to database two. So something like that. Every time you need to switch the databases. If you have 20 applications, you have to connect to 20 different databases, correct? And even as I said, databases does not store historical data. This will maximum stores 30 to 90 days of data. So we don't prefer OLTP systems for reporting. That's the reason why we don't we don't work on OLTP systems. There are cases where we can create, we can connect, but in general, that is what the best practice where we are going to create reports on top of data warehouse. Okay. So let's say a simple example to understand. Let's say if you have to complete your master's, there might be 4 or 5 subjects where you have to complete. So let's consider that like this is subject 1, subject 2, subject 3, and subject 4, and you have to attend these 4 classes. If these 4 classes where you if you are have to attend these 4 different classes in 4 different college or 4 different universities, right? It will be very tough, right? If you want to attend 4 different classes in 4 different universities, it will take time. You have to complete the first class, again you need to travel back to the second university to attend the second class. You have to manage the time and how to concentrate on the, I mean, the timings and also the distance and the location, correct? So that way it will be very tough. But if you have all the subjects in one single university, that will be very easy to access, right? That's what a simple example. Okay, so I mean, databases are like individual databases, like these individual applications, but data warehouse is nothing but it's collection of all the applications which is subject oriented. Clear on? So data warehouse will store all the historical data. So these days, right, we don't create reports on top of 50 years of data or 20 years of data, even though we have data. But generally we used to create reports. I do feel maximum 5 to 10 years. Okay, they'll consider 5 years. Even for a banking domain, I have seen they're considering the 23, 24 months of data. They won't consider all the historical data. Depends on few of the applications, but they won't consider all this vast or the huge data. Okay, so they are restricting, they're doing analysis like past 5 years or 2 years of data. Clear all? Any questions on this life cycle of data warehouse? So we have databases, that is OLTP systems, and there is an ETL team. We don't worry about ETL process. We are not into ETL, we are into reporting. So their main job is like they have to do some transformations and they will load the data into data warehouse. Any questions on this life cycle of data warehouse? So that will jump onto this. But as I said, this is, I mean, even as I said, like if you have historical data, let's say 4 years of data, let me give you an example here. So you have a flexibility where you can compare year over year growth. Okay. So when you look into these details, if you have 4 years of data, I'm comparing, you can see when you compare 2019 to 2020, there is a reduce in the sales. You can see the numbers are reduced when you compare with 19 to 20. 2019 sales is 484K change. 2020 is like 470K change, right? It's got reduced, correct? How much reduced? Minus 2.83 percentage. Understand, right?
Mhm.
So if you look into this 2021, like when you compare with 2020, 2021 sales got increased, the huge margin where you can see 30 percentage, close to 30 percentage increase in the sales in 2021. So that is what we use to compare, right? Generally, why do we compare? I'll come back to that. So comparison helps. So that is what time variant. Time variant is also same. Like time variant is also nothing but uh, it stores historical data. But generally, time variant is nothing but we have uh, we have historical data in general. What is the advantage of time variant? So for the advantage of time variant is like you can compare the data. You can compare the data. Example like current year sales. Current year sales versus previous year sales. Understand, right? So if you have historical data, you can compare the data. But as I said, let's say if it is a non-time variant, if it stores only 30 to 90 days of data, we can max compare with month to month, like last 3 months. That's it. We don't have even 6 months of data or 1 year of data here. Clear all? With OLTP systems, that's the reason we don't prefer. This is one of the reason where we don't, but this is what the functionality of OLTP systems. We don't store all the historical data because of this centralized database. But basically, if you have a historical data, the advantage is you can go for comparison. We can compare the data like current year to previous year. That is what for better business analysis. What is the advantage of historical data? For better business analysis, we used to compare the data. Understand, right? Why do we compare? Is like just for better results. Okay, I'll give you a very good example here. Like I think I have showed earlier, but when you look into Wikipedia, any of the organization, right? Let's consider Walmart, Wikipedia, Walmart. As I said before, 3 to 4 months before, I do feel like 2 months before, or in the COVID times, everything is green. Everything is green in COVID times, with total assets is also in green indicator. But nowadays I can see there is a reduction. I mean, comparison over, we can see physical year, right? Like kind of a quarter to quarter comparison. Okay. So you can see this indicator, positive green indicators, which shows positive results. If you have a red indicator, which shows, I mean, they're comparing with current quarter to previous quarter, something like that. And even the stores were increasing now. So, but the last time we can see every time the stores were decreased with the COVID-19 restrictions. Now you can see there is an increase in the stores when you compare with previous month or previous quarter. Clear? So this is where the comparison helps. And when you compare, you'll get to know that, okay, I got positive or I got negative. Based on that, this indicator shows that we are doing good, right?
Yeah.
Even in the stock markets, right? So you have a like opening and closing balance, opening value and closing value. So if open value, I mean, the close should be greater than open value, right? That is what the logic, something like that. So that's the point here. So based on that, we are displaying some indicator, green arrow, up arrow, and the red indicated down arrow, something like that. So here all. So this is subject oriented, where it's like, you know, all the applications data. Time variant is also like similar to historical data, where it shows all the historical data. What is the advantage of historical data? It's like we'll compare the data for comparison, right? We can compare the data so that it helps for a better business. So that is the advantage of historical data. Data is very, very important. Okay? So data is very important. I mean, in general, as I said, four important points, like what is data warehouse and what actually subject oriented, time variant, non-volatile, and integrated. So these 2 points. Any questions on this? And this data warehouse for sure, like we are not doing much practicals, right? So here, completely into theoretical. So probably you'll get a lot of questions. If probably you might not get all the points, but for sure I will try to relate with Tableau. Okay, most of the part. Even we have an important concept called as data modeling, which we are going to start tomorrow. Like, I mean, we have facts and dimensions. After completion of facts and dimensions, we'll start the data modeling concepts. So there is a point called as non-volatile. Okay, volatile databases, generally volatile databases is like um, is nothing but it's completely related to access. Okay, but just remember that as a reporting person, as a Tableau developer or as a reporting person, we can access databases. Okay, we do have access to database, and right, we can access database, but we have only access to select statement. We can go for only select statement. Clear all? So we generally have access to select statement, and we don't insert, we don't delete the data. Understand, right? So, but basically for the DBAs or the database or the ETL person, they have access to insert. They can insert the data. They can update. They can delete. They can do some selection, right? They can create everything. So it is purely related to the access. So for as a reporting person, as a reporting person, so we don't have much access to the databases. Like we have only access to select statement. For sure, we have access to the databases, okay, because we can check the data, we can try to execute some set of SQL queries and validate what data we are getting. Okay, database access is important, but we don't have everything. Like we cannot delete data, we cannot insert new data. That is completely restricted. Okay, so that is what non-volatile. So we don't have, we are not going to change anything in the data warehouse level. It's non-volatile is like not change. I mean, volatile database like kind of a keeps on changing, something like that, right? So non-volatile is like purely access related thing. So purely access related permissions. So we have only access to select state. And for the database developers or the ETL persons, they have access. They can insert the data, they can update, they can delete. Okay. So this integration is the last point where integration is like it's like a summarized. Okay, it's like a summarized, or generally, as I said, daily CSV files, right? So we'll get the lowest level of granularity every time we do get low level data in real time, right? So we'll get a low level data. I mean, or level of granularity, lowest level of granularity. Non-integrated is like, so basically it's like lowest level of granularity information. I mean to say like day level. Let's take an example of day level. Okay, but like there are cases where we are going to showcase the data across day, month, quarter, and year. Correct. A perfect example is like COVID-19 cases. Okay, a very good example is COVID-19 cases where generally we have this COVID-19 cases across the lowest level, like a city level or somewhere like some cluster, correct? But on a high level, we are seeing like country level, right? Understand, right? So we are going to say that, hey, we do have this is what the United States count, and this is what India number of cases, this is what Brazil number of cases. So that is what on a high level we are looking over the data, but generally we'll get the data across the lowest level for each and every city wise. The number of cases we can consolidate across state level and into country level, and then we are going to tell that, hey, these are the total number of cases today, or these are the total number of cases for this particular country over the period of time. Correct? So that is what integrated is like the summarized data. Basically, we can agree, I mean, we are going to showcase multiple levels of granularity. So that is what lowest level of granularity. So generally, we'll get the data across low level. I mean, every time we do get the low level data, that means, let's say, even your transaction, right? So let's say if you're going to do some transaction, that will be stored in a daily transactions, correct? Date and time and the transaction amount. But on a high level, let's say in the yearly, how much amount withdrawn or how much amount debited, credited, right? We'll get that information, consolidated data, correct? So that's the point here. I mean, I do feel the COVID-19 cases is the best example where you can tell that, hey, this year, I mean, like, even you can compare 2020 to 2021, and because I have done that actually. So I have created COVID-19 dashboard, and let me show this that on top of data, like the real-time data. Even we can create dashboards on top of COVID-19. We have real-time data from WHO. We can prepare that. We can. I'll showcase how to create from scratch, like how to work with the visualizations and all these things. Okay. This is a modified version of COVID-19 dashboard. I have the original version. I'll showcase that, but this is a different request related to vaccination. And okay, you can see first dose versus second dose. But this is the actual data. When you look into this, so when you look into this map, right? Map visualization. So this is what, when you mouse over California, you can see the number of cases and number of deaths, and Texas. I mean, this is the data. So data speaks, I mean to say, right? So that's an example. Like basically, you have this information, and when you mouse over, this is what the total number of cases, right? Something like that. So clear all. I'll showcase the actual version of COVID-19 dashboard. I'll showcase how to work with COVID-19 dashboard. This COVID-19 WHO COVID-19. This one. So this is the dashboard I have created. Okay, I'll showcase that. Probably I need to search. I'm unable to get directly the workbook, but this is the data we are getting, right? The total number of confirmed cases, persons received booster or additional doses, 29.32% boosted per 100. Understand, right? This is the data. Like we have the data. Even we can download the data. So I'll showcase that. You can download the data from this website. You can see download map data, right? So where you can get the information of. I mean, you can download the COVID cases information, and also uh, the vaccination data. You can see this is the data where you can download. Clear all? So I'll showcase that. I'll give you those examples. But this is what the basic data warehouse and the life cycle of data warehouse. And if someone asks like what is data warehouse, you can tell it is it stores historical data, and it is subject oriented, time variant, non-volatile, and integrated. Okay.
Okay.
And I'll repeat a few things tomorrow, the same on something like a quick recap, and we'll start facts and dimensions. Importantly, like the data modeling concepts after completion of this. And I'll showcase the terminology. I'll showcase the data modeling concepts related with I will practically show in Tableau level so that you'll understand how we are going to establish relationships between the tables and everything. Clear all?
Yeah.